Good afternoon, everyone. Welcome back to a lecture after your test week and a weird long weekend. I hope your test week went well. So far, the MGC results look pretty okay. So I'm hoping all the other modules went okay for you guys as well. Before I start the lecture, are there any questions on anything that you're wondering about? Feel free to type. Okay, so the marks are still busy being processed. There's a couple of drawings that need to be marked still. And after that, the marks have to go to the head of the department for signing off. So it should be out probably next week sometime. The drawing practical marks would also probably be out by next week's practical. Semester tests count, I think, 30% each of your semester mark. So if you view the daily timetable, you would notice that there isn't a practical this week. So in tomorrow's practical, you will be doing some non-MGC related stuff if you want to. Is there anybody else experiencing issues with the sound from our microphone? Okay, cool. Thanks. So it seems the sound is okay. There will be 2 semester tests in total. Thanks for the feedback on the sound. Okay, good. So for today's class, we are doing auxiliary views. It is not a problem if you fail a semester test. You can make up for it in the second test, or even if you failed both of them, there is still many times enough room for you to make up the marks later on still. So it's not a big deal. My personal record was a 23.5% for a semester test, and I still finished the module with, I think, 67. So I got like 23 in the first test, and then I studied really, really hard and made sure I understand what was going on. So I got, I think it was 80 something in the second test, and then all was okay after that. The only problem is if you do very badly in both tests, then it's a bit tricky to still um, enter the exam with enough momentum that you can afford to trip in the exam as well. There is always hope, definitely. And without being funny, even if you fail a module, so what? Failing a module at university is actually not that weird of a thing to happen. Of all my friends, I think we were about half of us finished in 4 years, and of those half of us that finished in 4 years, probably most of them failed a module somewhere. The MGC marks would hopefully be out by next week's practical session. Okay, so if you found that there's a different way to take the pictures and send them through as a PDF and the quality is better, no problem at all. The better the quality, the easier it is for us to actually mark the stuff. So if you find a way to improve the quality, go for it. Well, I actually do get people who fail MGC as well. MGC typically has an 80% pass rate, so most people are okay with MGC. But please remember, it is definitely not the end of the world if you fail something. I also failed 2 modules in my 3rd year, but I got to do the supplementary on those, and if it weren't for the subs, I would have failed those modules. So that sucks. I'm glad the subs were there though. The one was calculus, so calculus wasn't fun in our 3rd year. 10% penalty. I'm guessing if you hand it in late, then we basically take your mark. Let's say you got 53%, then we just subtract 10% from that. So then your mark that goes through to the calculations would be 43. Yes, if you fail MGC, you can do it next year again. And I've also, from this year, started a winter school program. So if you failed MGC and it's like the only one you failed, then you can do a winter school program which will take place probably somewhere end of July or so. And then you can basically do a crash course on MGC which has semester tests and an exam in it, and then you finish with MGC this year still. So then no ripple effects into your studies that could cause you to study longer. So that facility is available. Otherwise, if you fail MGC, you can just take it again next year, first semester. It is not presented as a second semester course. So just a question that was asked a bit earlier, what did I study? I did mechanical engineering. What do you do if you fail? First, you tell yourself it is not the end of the world, but it isn't. If you fail, you simply register for the module again next year. You are allowed to fail a module more than once. Usually the rule, depending on how many modules you fail. For example, if you failed all of your modules in your first year, then you'll probably get a letter saying that, listen, maybe this course isn't for you. But if you failed 1 or 2 modules, you can actually take a module up to 3 times, but you have to pass it on the 3rd time. So calculus also has winter school programs. So if you fail it, you can do it right after this semester in the holiday period. You can do calculus then. If you fail that or don't get admitted to that, then you have to take it again next year, because calculus in the 2nd semester is a follow-up on the one of the 1st semester, meaning you can't take a course and its follow-up at the same time. Depending on what you study, MGC can be a prerequisite. So if you're studying industrial engineering or mechanical engineering, then MGC is a prerequisite for MOW 217. So if you fail that and you're one of those disciplines, then you will probably end up studying a year longer. If you're studying anything other than mechanical or industrial, then you should be able to squeeze MGC in between the others without studying a year longer. So winter school programs, I think if you go onto the university's website and you just search for winter school programs, you should be able to find it there. There is not a winter school offered for all of the modules. It's only for modules that have a high enough failure number for them to justify presenting the second course. Oh, thanks. My long weekend was pretty good. I was fixing my wife's car because she drifted it around the corner and broke the differential in half. It sounds more fun than what it was. So, application for winter school, there are some requirements on applications for winter school. Basically, what you need to do is you need to have the entry requirements for winter school. So you can't just run a winter school without taking the main module. And if you fail the main module, usually the winter school, like for MGC for example, I expect a student to at least have had exam entrance, so a semester mark of higher than 50% to be able to do winter school. So that we can't just have people who never did the main course and then want to try the winter school. I think that would be unfair to them because unfair to the student because it's actually more work than what someone can just quickly do. So you apply for winter school by following the instructions on the UP website. For MGC, you have to first fail the module and then you send an email to myself. Personally, I never had to redo an entire module, but looking at the students that go through the department, I think it's definitely doable or manageable to actually squeeze in another module. Remember, when you redo a module, most of the content is known. You just basically need to refine your skill or knowledge on the content. So it's not, although it's a 16 credit module, it's probably only 8 credits worth of work. I'm not sure what you mean by prerequisite for mechanical engineering. Um, Based on school marks, those figures I don't know. But you're here already, so I don't think that's what you mean. For mechanical engineering, this semester you have to pass your MGC course to be able to go on. Yeah, as I said, it sounded like fun with the diff that she broke, but it wasn't so much fun. She was just overtaking someone around a corner and floored it, and it started spinning and then broke the diff. Okay, basically, if you're doing industrial engineering, um, you have a follow-up module next year called MOW 217, and you have to pass MGC to be able to do 217. Yeah, it was somewhat expensive to fix, not too bad. I did all the labor myself. So MGC is not presented again to the industrial engineers in their second year, but the follow-up module called MOW 217 is. Basically, a credit is basically if you pass a module, you are awarded that module on your academic record, and it basically counts towards your degree. So a typical degree needs a certain amount of credits or hours of work, and if you add up all the module credits together, then your degree must be bigger than a certain amount of hours. That's a good idea to charge her for the labor and the costs. Although she paid for the costs. We both paid for it basically, but I might work out something. Your next MGC practical will be due next week, so you don't have to worry about anything like that now. Yes, I did vehicle engineering as my elective in my final year. It's a ton of fun. MOW is similar to MGC. It's basically just a build on that. Anyway, let's start with today's class. I think I've answered most of the questions. What do you mean we're not doing anything today? I'm busy talking to you now. So no practical this week. You can check it out on your daily timetable. It's actually written there as well. Your marks should be out by next week's practical. Okay, let's start with the class. Otherwise, we're not going to get through everything. It depends on what 2 or 3 modules a student fails. So if you fail your core modules, all your core modules, then it might be a problem. But if you fail one of the less critical modules, then 2 or 3 should also still not be a problem. Now, if you fail EBN, remember each module is basically a course on its own. So if you fail EBN, it doesn't influence MGC. So when you fail EBN, you have to redo EBN. EBN is presented in both semesters, so you might even be able to take it second semester. Although I'm mechanical, not electrical, so speak to those guys about that. How should you decide which engineering suits you? Well, that's a very long question. I think you can maybe speak to the faculty student advisor on that kind of thing. There isn't a tutorial tomorrow, as it says on the daily timetable. No tutorials this week. The core modules should also be in your departmental study guide, or there was another word that someone used just now. I can't just remember what the word was. The yearbook. It should be in the yearbook. Thank you, Anina. Tomorrow is just a normal Thursday. Okay, I'm now going to start with class. You have already started to use SolidWorks in NGC's classes, but practically speaking, depending on what you study and what you're doing, it might be second year up to final year. Okay, so today's class, we're speaking about auxiliary views. So, let me quickly show you what I mean by auxiliary views. Here we have a little box, and if we want to dimension it, we can give a main view, we can give the width, we can give the height, we can give the location of these screw holes, all of that. We can do a right-hand view, show the depth, you can show the cone angle if you want, because it's slightly smaller at the back than at the front. We can do a top view to show these holes. We can do a left-hand view to show those insert holes. We can do a bottom view. So for this shape, our standard views, main, right, left, top, bottom, and back, are actually sufficient to be able to dimension everything in this block. But if we now have a component with a different shape, so over here I have my little precision scale. So there's the top view, and there you can see yourselves in the camera. Now you'll notice on this right hand side it is sloped. So if I wanted to give the dimensions for these 4 holes, I can't give it in the top view because they are actually at an angle. A very slight angle, but still an angle, meaning these circles are oval in the top view. And this rectangle, that line there, isn't the true shape. So what I'm going to need to do is I'm going to need to construct a view where I look straight at that surface. Typically something like that. So basically I'm holding it now with the front higher off the table than the back, so that we can view straight at the surface. So if I make an additional view straight at the surface, now I can dimension the spacing, size, and orientation of all of these features. So the normal main view, right hand view, and top view are not sufficient. I need to do some other extra view. And that is where our auxiliary views come in. So if you have a feature of a component that is at an angle, and we want to dimension that surface. Let's say you want to print a sticker that has to fit exactly onto that triangle. If you look at the main view, you don't see the true shape of that sticker. So you'll cut a sticker and it will not fit. So what we need to do is we need to turn or create an additional view such that we can actually see that full surface. Any view that is not one of your standard views, front, back, left, right, top, bottom, any view that's not one of those is an auxiliary view. Here's an example, a modification of that little friend of ours. So we now moved the hull from this surface to that inclined surface. So if we wanted to dimension this circle, I'm just zooming in a bit. That circle in the right-hand view is oval, and in the top view it's oval as well, meaning we can't dimension that circle in the top or the right-hand view. Also can't dimension it in the main view because it's hidden detail. We could probably make a little partial section and then dimension it like that, but that would only work if it's a circular hole. If it's a triangular hole, then all of them are useless. Then we have to make an auxiliary view to just show the detail there. So we look straight at the surface and project an auxiliary view to show the detail of that circle. At the top we have our three standard orthographic views, main view, right view, bottom view. But this hexagonal shape, the six-sided shape, is at an angle in my bottom view, which means I can't dimension the width from there to there because it is at an angle. So what I'm going to have to do is I'm going to have to look straight at that surface and draw an auxiliary view of that surface when I look straight at it. Now you'll notice in this case it was broken off, and this is called a partial auxiliary view. So remember, we only want to show what we want to dimension. So if I do a bottom view, then this part is straight and I can dimension on it. But if I do a view of this flat surface here, then that side of the component would be at an angle and I can't dimension to that. So I won't be able to give that radius if I just had the view lying at an angle. So what I do is I make two partial views, a partial bottom view to show the radius over there, and a partial auxiliary view to show the hexagonal side. So sometimes it makes sense to only show the dimensionable features. This is where a partial auxiliary view is of great benefit. There's no point in us showing the entire background like with this one. Showing that thing there is pretty useless because this is all skew information. I can't dimension to that. So I just want to show the part that I can dimension. So the hexagon is pretty easy. You just give the distance from that flat plane to that flat plane, distance from that one to that one, and the distance from there to there. If it is a perfect hexagonal shape, you can even give it a center mark and a constructed circle through all of its tips. Okay, so now the question is, how do we actually construct these auxiliary views? So that example has a cylinder that's cut at an angle. It has a circular cross-section viewed from the right. So basically what we do is we want to show the true shape of this surface. So we must look straight at it. I'm just going to darken these lines so that I can darken my construction lines and that you guys can actually see what I'm drawing. Okay. So I want to project it at an angle so that I view straight at that surface. Now we must place this view somewhere. The exact location isn't important. So I'm just going to make a reference line over there. And I'm going to place a reference line, in this case, through the middle of the circle. The exact location of the reference line is irrelevant because it's just a reference. Now what I'm going to do is I'm going to divide the circle into 8 equal parts. There we have 8 equal parts. And I'm now going to construct each of these points in my auxiliary view. So point number one lies on my reference plane. So I move it to this reference plane. It is still on the reference plane. There's point number one. Point number two. Now point number two is a certain distance from the reference line. I'm just using the ruler as an example. Obviously when we do this in class, we're not that worried about it. So that's about 8 millimeters. There's point number two. Point number three is a bit further out. Point number four. Four and two are actually the same distance from the reference line. Point number five lies on the reference line. 6 is now to the left of the reference line. 7, 8. And now I'm just going to construct a smooth curve through those points. Something like that. So that means that oval is now the true shape of that surface. You can see it's not circular anymore, it's slightly longer. If you wanted, you can even transfer the background information over. Okay, the background information isn't important at this stage. So these lines are not specifically at 45 degrees. These lines are perpendicular to this surface. In other words, if the cylinder looked like that, then that angle would be 90 degrees. So point number 1 and point number 5 lay at the top and the bottom of the circle, which lie on the reference line. So if I construct it over, that's where point number 5 lies in my main view. And perpendicular to that, that's where point number 5 lies on the reference line in my auxiliary view. No, you don't have to draw the background information. I just showed this process now so that you know where it comes from, or if you can't visualize it, then you at least know how to generate it. What is a A-type and a B-type line? A thick line or a thin line? All solid lines, outside lines are thick lines, and all construction lines are thin lines, which we erase afterwards in any way. So I'm assuming you're speaking right side view of that one. If this one is perfectly circular, which is what I tried to do over here, then this one would be oval, meaning the distance from 1 to 5 is bigger than the distance from 3 to 7. In the second one's case, it would even be a lot longer shaped. So in an auxiliary view, we're generally going to do partial auxiliary views, meaning we only draw that which we want to dimension, and we don't do the background information, which is now skewed. Yes, we do erase our construction lines. Remember, it's freehand drawing, so you don't have to use construction lines for every little thing. I used construction lines now so that you guys can follow the reasoning, but you don't have to make a drawing. It depends on the question, but generally no, we will only do the partial views. Okay, so divide it into a number of points, transfer the information over, repeat for all the points, and complete it. In this example, again, we showed the background information, but we'll explain now why it's not necessary. It is useful to only show that segment of the view indicating the true shape of an object. So in this one's case, showing this cylinder in my top view would be useless because I can't dimension to it. Remember, our drawings are not made for fun, they are made for dimensioning purposes. So you want to be able to specify the size of the part so that someone can actually manufacture one exactly the way you want it to be manufactured. So, partial auxiliary views is basically where you only show what you can dimension. So in this case, a top view would be broken off over there. We just ignore everything to the right of this broken line. But to show this cylinder, we make use of a partial auxiliary view. So we do a partial auxiliary view just of the cylinder and a partial top view just of the rest that isn't shown in this view. Please note the break line is a wavy, usually thin line, freehand line, and it doesn't exit the part edges on the sides. Generally, you might be marked down for construction lines. I won't guarantee that you will lose marks, but you won't lose marks for not having them. So rather just erase them. Here we have examples of partial auxiliary views. There we have a component, and we made an auxiliary view of this inclined shape over there. That's the auxiliary view. But now all of this background information is actually pretty useless. I can't dimension to any of that. So drawing it there is adding lines and time to a drawing without adding any value. The same with this bottom view, which has this background detail visible. So a better way to do it would be to make use of partial views. There's a partial bottom view and a partial auxiliary view, only showing that which you want to dimension. Just another example of this. If there was enough space over there and the cross section didn't change in the length, you could have made use of a revolved section, but you could also just make use of a partial auxiliary section view. So here is a quick auxiliary view example. Let's quickly do this one together and then we'll do another one as well. Okay, so there's the example. Now, let's start with the question. So we're drawing that's our main view. Now, if we do a left-hand view of this, remember now that this information is a cylinder or a circle that's been tilted into the page. So now you see a round circle becomes an oval if you tilt it. Meaning showing this plane in the left view is kind of pointless, because it's not going to contribute to any dimensions in the view. We can also do a top view. But now the problem is with our top view, we can't do a partial top view because then we're going to kind of mess up the top view. You can't only draw a part of the top view. If I draw the right hand side, then I miss these holes. If I draw the left hand side, then I miss those holes. So in this one's case, I'm forced to still draw the skewed information. Okay, this is now an oval. So to draw the true shape of this plane, I'm going to project perpendicular to that. Nasty skew line. So this is now a partial auxiliary view to just show the information on that inclined plane. I see, I just want to quickly edit this radius over there. It was more right initially. No, you don't have to draw the skewed info at least once. That's the whole point of the partial or auxiliary view. It depends on the application. You'll see in the next example that we actually don't draw the skewed information once at all. I suppose you can add a sectional top view, but you won't really show better information than what you're doing at the moment. Remember now, if you make a sectional top view, let's say you make the section on this top surface over there, then the top view would actually be a lot more work to draw. I'm just drawing it quite rough now. And you're still going to end up with weird, hard to dimension features. Okay, so depending on where you made the section line, if the section line goes through there somewhere, that whole view will be hatched. So that's a lot more effort and less clear than what this skew information would have been. Yes, everything that we're going to do with weird shapes, we're actually going to try to make use of an auxiliary view to define the shape better. So the question would usually be make an orthographic drawing of the question given and show all information meaning you might need to make an auxiliary or partial auxiliary view to show all of the information. Okay, so just to explain why the left view doesn't show the slanted information, one could add it over here, but you can't dimension onto that because it's skew. So there's no point in showing it there if you can't do anything with it. And that's why we ended up not drawing it. Okay, good. I'm going to quickly move on to the next one. So for this next one, we need to show all of the information in that drawing. And let me just quickly draw it for you. We're going to make use of a main view. And I'm just quickly drawing it and then I'll try to explain it before the time runs out. Partial top view. Partial auxiliary view of that surface. And a partial left-hand view. Remember now all of this information towards the top is pretty useless information because it is at an angle. Last thing to do would be to add a partial bottom view. Okay, something like that. Now, let me quickly explain what's going on over here. I chose a main view based on the view that shows the profile the best. If I chose this view as the main view, then I would have had to construct an additional view before I could make my partial auxiliary view. So that's why I chose this one as my main view. Partial top view to show that semicircle over there. My break line was somewhere there for the top and somewhere there for the bottom. And that's why it's consistent in the other two views as well. And then you can add center lines, hidden detail, and dimensions. Well, I suppose you won't specifically lose marks unless the question specifically asks for a partial auxiliary view, but you won't directly lose marks, but the time you spent making all the background information is time you could have spent on something else, which might end up costing you marks. Okay, I just explained the main view thing. Okay, so basically what I did is I did a partial top view just to show that, and I did a partial bottom view to show the bottom holes. I could have gotten away with just the partial or like a complete top view, but then I would have had to have all this skew information and the edge would have overhung over there. So I basically chose it that way just because it's clearer to do. Typically in an assignment, we will tell you guys, do a partial view from the left-hand side, a partial top, a partial bottom, and a partial auxiliary view, as well as a main view. We'll typically describe it in the question. So no, there's no specific rule as to when you will use a left view or a right view. It depends on the question. You don't have to label a partial view. You noticed that I didn't even show the arrow, which is the viewing direction. Don't have to do that. Yes, remember we actually only do orthographic drawings so that we can dimension the stuff so we can have it made. So the primary objective of drawing orthographically is so that you can have components manufactured. And you can only have it manufactured if you can tell the person how big it is. So the break lines basically just show where the view stops and where other views will continue. So it's basically like zooming in. It's like when you take a camera and you zoom in so closely that you cannot fit in everything into the shot. That's basically a partial view. Okay, let me show you why you can't dimension something that's skewed. Let's take this pen for example. If I want to dimension the length of the pen, it is 142 millimeters or something. If it's at an angle, placing the 142 like that is considered incorrect because now this line is actually not on the page anymore. It's floating in the air while the right-hand one is on the page, which technically you can give the value, but practically speaking, then what are you going to do if in another view you're drawing the cap and now suddenly in a different view the cap looks almost as long as the entire thing. So now I'm putting a dimension on this, which is 40 or whatever, but now my 40 and my 142 look almost the same, which means your whole proportion and scalability of the drawing is completely lost. So we never dimension to something that is skew. There could be hidden detail in auxiliary views. It depends what you want to show. Yeah, so basically you do understand it, right? But remember that we don't want to draw the skew information because it's kind of pointless, it takes time and wastes real estate on your paper. So in this one's case, remember I'm looking at this surface. So my right hand side would be closest to myself. The left hand of this view would be into the page. So that's why this one lies on that side, because in this view it's on the deep side, it's not on the front. So you must now imagine, let's say this is you, the observer. You're viewing it like that. So whatever you see on the right hand side is closest to myself, and what you see with your left eye is deepest into the page. And then you draw what you see there. Okay. Yeah, so you can make use of whatever view necessary to be able to specify the information that you want to give. So the auxiliary view won't be oval. If we just go to this example, that will not be oval, but this top circle, if I draw it there, will be oval. This one here, the top is over there, center of the cylinder is over there. Bottom, top, bottom, top. So in this one's case, it will be oval. We can show hidden detail in an auxiliary view. It depends on the application. In these ones now, it was not necessary. So the advantage of using the break lines is it allows you to show where the component has a physical thing happening and where your view is broken off. If you put those on the same place, it might cause the person reading the drawing to not understand exactly if the straight line is the break or whether that is actually a feature that you're showing. So I suppose it depends on the application. You can send your practice drawing to our instructor. His details are on ClickUp. You will probably not lose marks for drawing hidden detail on isometric drawing, but you will lose time if you do that. Okay, I see we are over time now. So thank you for attending. I hope you have a good evening.